Okay, pause the video, copy these down, and give them a try. I will solve the second one. Okay, pause, copy, try. First one, you get, well, I'll write it in a funny way, minus 50 e to the negative 0.02 x plus constant. Okay, I'll note that minus 50 is the same thing as 1 divided by 0.02. Okay, the part B, I'll go u is equal to the inside function, ln of x. du dx is 1 over x. Dx is x du. Okay, I can do this quickly because I've done it for many years now. If you don't be afraid to copy this down, try it on your own. Solving for dx. Okay, perform my substitution. I get u to the 7/2, still divided by x, and then x du. I get cancellation I was hoping for. I'm a happy camper, as usual. U to the 7/2 du. Power rule. Power rule, I add 1 to the exponent, giving me 9/2, and then divided by also 9/2. So that's 2 over 9 u to 9/2, which is 2 over 9 ln x 9 over 2 plus constant. Double check, because to err is human. Yep. Okay. So what should we talk about next? I got lots of examples here. How about e to the 2x all over 1 plus e to the 2x dx. Now, choices. Let's have a look at something we did above. Let's have a look at, let's go all the way back up here. I hope I'm not giving you a headache by scrolling here. Is this the first example? Okay, first example. Let's have a, what happened? First example. Let's look at the first example. Oh boy, what's happened here? Have I deleted everything? Oh no, I just switched pages. Okay. Sorry about that. First example I did in substitution. Why? I want to talk about why this worked. Well, it worked in the sense that I got this cancellation I wanted, all my x's disappeared. Now, let me just say something. Here is u, right? And then directly outside, what is that? Well, that's u prime, right? So what we're doing with chain rule, what we're doing with substitution is we are kind of reversing, reversing chain rule. Okay, so for that reason, if you have a choice of u, right here, and then directly outside you see u prime multiplying, then that tells you that substitution is going to be, this substitution is going to be perfect. It's going to work out very nicely. So you want to think about u. You want to look outside. Do you see u prime outside? Or I think you'll notice that if this weren't a 4, that wouldn't be a big deal. Okay. It was especially nice that this 4 canceled this 4. But really, what I want is I want the x's to cancel. So if you see u here, you see outside, u prime or some multiple of u prime, then you know that you are on the right track. Okay, let's go back to, scroll down to the example in question. Sorry about this. Okay, now what I want to say here is I want to say, look, this integrand is equal to e to the 2x. And I can write this as 1 plus e to the 2x to the minus 1. This makes it a bit more clear. Here's my u. And then outside I have, well, not quite u prime. I get u prime, but looks like it's u prime. What is u prime? U prime is 2e to the 2x. So this would be u prime divided by 2. But that is good enough. It's good enough for me to be very confident about making this choice for you. So I choose u, take a derivative, solve for dx, and I get half du over e to the 2x. Plug that in, and see what happens. So multiplied the u over e to the 2x. So I did my substitution, and as expected, the important cancellation occurs. I got this ugly half here, but not a big deal. So I get 1 over u du, which is my ln absolute value of u. Should be equal signs here. Slappy, slappy, slappy. Half ln 1 plus e to the 2x. That was my u there. And further simplification is to just say that my u here is never negative. Never, never, never. So I don't need the absolute values. Okay. So I talked at the beginning of this example about, I guess, about strategy. Okay, why is this a good choice? You may look at the original integrand and say, oh, look, what about 2x? Well, that wouldn't be a disaster, but I hope you agree that from what I was talking about here, this is a much better idea.